add up the first 10 square numbers, 1, 4, 9, 16, and so on. Most people just start adding. The answer is 385. There is a formula that gets you there in a single line, and it is one of the ugliest things anyone is ever asked to memorize. N times n plus 1 times 2n plus 1, all divided by 6. But where does a 6 come from? Nobody ever tells you. By the end of this video, you will not be memorizing it. You will see it. Here are the first 3 square numbers drawn as actual squares. 1 cell, 4 cells, 9 cells. We want their total. And the move that unlocks the whole problem is this. Instead of drawing 9 cells for 3 squared, just write the number 3 3 times. Same value, far more useful shape. Do that for every square number, and the pile becomes a triangle. Row 1 holds a single 1. Row 2 holds 2 2s. Row 3 holds 3 3s. Every row adds up to a square number, so the whole triangle adds up to exactly the total we are chasing. Call it S. Now, the trick, take that same triangle and turn it by 1/3 of a turn. Then turn it once more. 3 copies, identical in every way, except which corner is pointing where. Each one holds S, so together they hold 3S. Now, stack the 3 triangles, cell on top of cell, and add the 3 numbers sitting in each position. Every single cell gives 7. Not most of them, every one. And 7 is 2 times 3 plus 1. In general, 2n plus 1. So 3s equals 7 multiplied by the number of cells. And how many cells are in the triangle? 1 plus 2 plus 3. That is the triangular number, n times n plus 1 over 2. Here it is 6 cells, so 3s is 7 times 6, which is 42. Put the 2 pieces together. 3s equals 2n plus 1 times n plus 1 over 2. Now divide both sides by 3, and the formula simply falls out. And look at where the 6 was hiding all along. A 2 from counting the cells of the triangle, a 3 from using 3 copies. 2 times 3, 6. It was never a random number. Check it against the picture. For n equal to 3, the formula gives 3 times 4 times 7 over 6, which is 14. And 1 plus 4 plus 9 is 14. So it was never an ugly formula. It is 3 triangles and a little bit of counting.